Alright, this is test 2 wrapper. I chose problem 3, the one with the energy plots. So first I'm going to tell you I have my friendly Crayolas. The green will denote energy total because we need to be a greener energy as a population in general. And kinetic energy is blue and potential energy is red because that's the way it is. So to do these problems, the first one we have 2 electrons some distance apart and at rest. So the very first part, the initial R, at rest means that we'll have no kinetic energy. So our kinetic energy will start here. Potential energy of electricity is inversely proportional to 1 over the distance that the 2 electrons are apart. But because they're both electrons, their charge is the same, so that'll be positive. So because the energy is always the sum of the K and the U, so energy will be positive here. And as we approach infinity, the potential energy will go to 0, and the kinetic energy will approach the total energy because the potential energy eventually be 0 at infinity. And so there we go, number 1. Okay, number 2, moving on. Next we have a comet as it approaches the sun, but does not orbit the sun. So our initial point is we have the minimum distance that is between the comet and the sun when it passes by its closest point. So again, to determine if we have energy or not, I like to think about it at infinity. So at infinity, potential energy will be basically 0, but the comet will still be moving, so we'll have some kinetic energy. So it tells us we'll have some kind of positive energy. So I'll draw that green line. Potential energy due to gravity is inversely proportional to -1 over the radius. So from our minimal point, it's going to be greatest, and it's going to approach 0. And then kinetic energy is going to asymptotically approach being the total energy. So that's problem 2. Moving on to the last one. In this last scenario, we have a spacecraft leaving Mars with an initial velocity below the escape speed. So the 2 points that we need to track are starting from the radius of Mars, so when it takes off, that's the closest it'll ever be, and then this last point, which I'm just going to call the fail point, at which it fails to leave the atmosphere. So once again, the first thing to determine is, do we have energy, and is that energy positive or negative? So when we get to this fail point, that's when the spacecraft is going to turn around and it will have no kinetic energy left. But it will still have some potential energy, which, and as we found in the previous problem, is going to be negative and inversely proportional to R. So it's going to be here. That's when it's going to be closest to 0, and from there it's really just going to be negative until we get to that. This is our energy. That's always the sum. Oh no, that's the wrong color. It's supposed to be green. This is our total energy. And the kinetic energy will start at some high point and converge to there. Eventually, it will be 0. So there we go. Test wrapper 2.